Welcome everybody out to the video that is discussing production laws in the Takt production system series. In this video, we're going to talk specifically about the production laws that govern the Takt production system and how they really keep the system on track. So I really like this opening picture here where we see this image of the train. And remember, the train is symbolizing the trades packaged into Takt wagons or boxcars in a leveled fashion, moving over the train tracks, which are the zones. In order for the trades to flow through the project, or in this case the train, to flow across the actual tracks, we must have leveled Takt wagons or boxcars. We must have a clear path ahead. We must have the right number of zones or spacing on the actual tracks themselves, and we must have leveled zones in order for it to flow. So it's a really nice analogy. So let me take you through this. The first production law that I really like to talk about, and yes, these are all translated from manufacturing background and from manufacturing in general. Do they apply? Yes. Are they translated to construction? Yes. But let me take you through them. The first one is Little's Law, which basically, summarized in construction, means that when you use smaller zones or smaller batch sizes, you will go faster. And so the Takt production system enables this law to be effective because it's measured by zones, or it's measured by batch sizes. The other thing that Little's Law says is that you will go faster. And when I say that it says this, meaning as it's translated to construction, that if you level work, that you will go faster. And so when you have work packaged as zones, you are able to level that work and keep an even workflow instead of a lot of spikes and ups and downs. And third, you will go faster, according to Little's Law, if you finish as you go. So that rhythm, you see these nines in the video, that rhythm indicates the end date for each of the sequences and puts it on a rhythm that can be measurably tracked as a part of the Takt production system, which means that we are finishing as we go in a leveled manner as well. So Little's Law, which is use smaller zone sizes, level the work, and finish as you go, is enabled by Takt because you're able to see all three of those. The really key point that I want to make here in this image, and I know that visualizing this is just a little bit difficult, but I do want to say that when you have a Takt time in zones, and you know that your zone sizes aren't ideal, you'll go slower. If you have work packaging that isn't leveled, meaning just like in this picture, this is too large for the actual Takt time and the zone size, you know that you're not leveled. And when the work density of the zone, meaning this zone is bigger than the other ones, you know you're not leveled. So if you ever see you don't have the right number of zones, that you don't have the right sizing in your work packages, and your zones are not leveled, then you are not obeying these laws. And so the other thing that I would say is, if your work begins to stack like in this picture, or if you stop finishing as you go, you are not obeying Little's Law. So the purpose of this picture is to show how quickly the Takt production system will show these things to you. The other one is the law of the effect of variation, which is absolutely fantastic. And so basically the law of the effect of variation simply states that as variation increases in the system, your duration increases as well. One of the things that Takt really does well is it keeps everything on a rhythm. So you see this sequence here, 1 through 8, right? If there is a delay, you're able to interrupt this in the Takt production system and use a buffer, and then start everybody back again, which prevents a lot of variation. So it keeps the pattern rhythmic, and it keeps it consistent, and maintains that continuity to reduce variation, which reduces your duration and any possible extensions because of variation. The third one is the law of bottlenecks, and basically the law of bottlenecks will say that, or it says that you will have a limiting factor, and that when your system has a bottleneck or a constraint, that once that is improved, first of all, your pace will be according to that bottleneck or that constraint. Once that's improved, more bottlenecks, more constraints will show up in the system. In the Takt production system, because of the way it's organized and because everything is organized as processes, you can see if a zone is too complex. So you see each one of these durations is longer. That means that there's a problem in the zone. So the zone is a bottleneck. If you see, hey, these threes are all longer than their intended duration, that you know that, then you know that that one trade is going too slow. That is your trade bottleneck. So you will see bottlenecks in the Takt production system usually as zones or as trades, and they will show up very easily in the Takt production system and be very visible. And so I love this concept of bottlenecks. When you have a bottleneck that occurs, and think of a garden hose, right? If it's kinked, do you get rid of the kink by putting more pressure on it, by turning on more water pressure, or by unkinking the hose, right? So most of the time people say, hey, I've got a constraint or a bottleneck. I'll add more people, more materials. I'll push them. I'll get extra crews. I'll pay for expedition. They're pushing, which doesn't make anything go faster. What they should be doing, like in this image, is to expand the bottleneck, right? Unkink the hose. Don't put more water pressure on it. For water pressure on it, unkink the hose. So remove bottlenecks and increase the capacity by having the right number of zones, leveling the trades, leveling the zones, having the train or the trades go the same speed, and removing roadblocks. So I really like that concept. The other one that I want to talk about is Kingman's formula. Now, this is very loosely translated from manufacturing to construction, but it is very effective. And so going back to this concept of being able to see problems inside the Takt system, if the zones are too imbalanced or the work packages are too imbalanced, one of the things that I really want to point out is that we think that a trade process or work package or scope of work, if it's a 4-day, that it'll fit within a 4-day takt time. But that's not exactly the case. So Kingman's formula, again loosely translated, says that if you have a trade process or work package, it's not just the duration of that trade process or work package, it's that plus the variation that that crew will experience or that activity will experience, plus any uh, loss of productivity from that crew for any various reasons. So you have the activity time, and then you have any additional time from low productivity and variation. So it's never just the targeted duration, it's always the targeted duration plus any variation plus low productivity. So that's Kingman's formula, loosely translated. And again, you will be able to see that because in the Takt production system format, in the Takt plan format, you will see if work packages fit or they don't fit within the system. So these are crucial to us maintaining production and construction, and you can all see them. You can see all of them rather in the Takt production system. Now, let's continue with the discussion on trade stacking. Trade stacking is the phenomenon that occurs when too many subcontractors or trades have been scheduled to work on a given area of a construction project simultaneously. So in looking at the image, too many trades required in the same area will slow down your productivity. Trade burdening is the phenomenon that occurs when subcontractors or trades have been scheduled to work in too many areas on the construction project at the same time. And this means when a trade is required to work in several areas and they're spread out all over the project, this becomes a very serious problem. And so when that happens, when you have trade burdening, you sustain a loss of production outside of these production laws because you start to batch. And so this is the first one I want to talk about. When you batch and you say, hey, I'm going to get for example, 4 things done, and then I'll move it to the next process, then I'll move it to the next step, right? Whichever one it is. It's going to take a lot longer. But if you do what's called one process flow, and you move one piece through the system at a time, it's going to move a lot faster and you're going to get the product more quickly to the customer. And so when you have a crew or a trade that has been trade burdened and they're being asked to work in multiple areas, now they're batching work instead of using one process flow. And the reason they lose time is because, a crew can think, oh, hey, I'm going to go work in this area, then this one, then this one, then this one, then this one, then this one. And they think that, they can get it done in time, but they can't, because every time they switch tasks or areas because they're overburdened or they're stacked, they lose time from what's called context switching, which extends the duration. What we really should be doing is just going and finishing one zone or one area at a time, task or area or zone A, task or area or zone B, task or area or zone C. Because when we're burdened or stacked, we are doing too many things with too much context switching, and we are losing production. The other thing that happens when we are burdened, meaning you have trade burdening and you are not keeping that consistent rhythm according to production laws, is that you have too large of teams. You're bringing in extra workers, your team sizes get very large. Look at this. If you have 4 people, you have 1, 2, 3, 4, 5, 6 lines of communication. Let's double that to 8 people. Now you have 28 lines of communication. So as the number of people on your team is linear, the communication channels becomes exponential, which makes it more complex to communicate and causes difficulty and a loss of production. The other thing that happens when you are trade stacking or trade burdening is that you may have a foreman and workers, but then when you change, you typically have to change foreman or add additional foremen to supervise the crews, which is detrimental to the cohesiveness of that actual crew. The other thing that happens in this image is if you had consistent workers in a crew, typically you have to split those up, onboard new people, and you mess with the dynamic of that crew, which loses productivity, going back to Kingman's formula, where you also have to count on the time that is accrued or added to the overall duration because of a loss of production. The other thing that happens is when you're trade burdened or trade stacked, usually foremen have to start overseeing multiple areas instead of focusing with their crews. So if you were on one project, you have 100% focus, 2 projects, 80%, then 60, then 40, then 25. After 5 projects, 5 areas, 5 zones, 5 things that a supervisor has to do when they're trade burdened and trade stacked, basically they're not supervising the 6th, and their focus and attention in order to even lead the work is greatly diminished. And so what I want to introduce is let's get out of that concept and bring back lean thinking. And lean thinking, as we've discussed before, is based on respect for people. 5S, which symbolizes a stable, clean, safe, and organized project. One piece flow, where we work in one zone at a time, flowing together, which is that we work on attack time, seeing together in these highly visible systems with this highly visible schedule, and then the team is able to improve. So let's go through these one by one. When we talk about respect, I've got some questions for you. Do we have nice bathrooms? Do we talk to the workers in the morning in a worker huddle? Do we have nice lunch areas to respect the people on our projects? Second, do we 5S, which is sort, straighten, sweep and shine, standardize, and sustain. Do we have work environments where things are easy to find, where the job site is clean, safe, and organized? Secondly, do we work in one process flow, where if we have a zone, we actually plan the work, do the work, and then finish and reflect and ask the crews, hey, how can we do better? When we do this, it builds in quality, it creates flexibility, higher productivity, frees up floor space, improves safety, improves morale, and reduces costs based on inventory and the inventory of materials. Number 4, when you flow, and as you can see in these pictures, you are seeing real-time schedules with the trades that are enabling the trades to flow from area to area to area and all go, as you see in these pictures, the same speed, the same distance apart, which means that they have ideal rhythm and speed together, because you are now no longer going the speed of your slowest trade randomly. You are going the common speed of the job site together. And then seeing together, having an office environment, visual controls, and office spaces where everybody can plan together and work together is absolutely phenomenal. And then actually from there, solving real problems together as a team. This is what we should be doing. So now that you know the production laws, don't go against them, right? Start implementing these lean techniques so that you can have ideal production on your project. And I want to bring you to this final image here, where we show basically in one image the Takt production system. So basically when you see a schedule with these beautiful colors and this cascading trade flowing from area to area to area, you are seeing a plan that's basically representing this train flowing down through the zones, right? in a rhythm, going the same speed, the same distance apart. And if you plan it first out ahead, build it right as you go, and finish as you go, you will be going at an ideal speed because you have the right number of zones because of Little's law. You will have leveled zones because of the system itself. You will have the proper takt time. You will have leveled crews, a clear path ahead, and leveled resource allocation. This is how you flow. It's not about adding labor. It's not about adding materials. It's not about throwing money at the problem. This is how you flow. And so I just want to bring your mind to this, because these production laws are a part of the system. If you follow the system, you will reap the rewards from the laws. I hope you have enjoyed this video. On we go.